Get started here, guys. Let me turn off the soccer commentary. Oh wow, yeah, they're all fixated on the TV. They're all like, it looks like, so the TV must be close to the window to the hallway, because there's just a bunch of people like there just looking, just staring out. All right, let me So I'm going to try to go through this somewhat quickly, because at least one of you had a question about stuff beyond the quiz. So let me get through this, and then we'll get to the question about homework that there was. Somebody had. So just, I'm trying to be brief here. The idea of this problem right here was based on the similar homework problems that you had to like identify graphs and so forth. And well, you actually had to make the graphs, right? Also, some of them. But anyway, that's obviously a circle. This is the equation of a circle. It has to be this one. So that's A. This has a horizontal asymptote of -4, as does this. That pretty much forces it to be this one. This one has a horizontal asymptote of 2, which forces it to be that one. This is the only one with a vertical asymptote, so it has to be the log. So because the log has, basically this is the shift of the graph of natural log 4 units to the left, right? So I told the previous section, I think a smart thing to put on your formula sheet would be just a brief picture of what does the graph of the exponential look like, what's the graph of the log look like, right? Just as a quick reference, so that if you have a problem like this, you can go, oh wait a minute, that's that one, and you can kind of, go from there. Notice that this one has -x, right? So if you think about putting in like a -1,000 into this, it'd be huge, right? So this one blows up for large negative values of x, which pretty much forces that one to be this one. Yeah. All right. So there's a quick rundown of that. Problem 2, a lot of you got wrong because a lot of you haven't studied the circle equation stuff yet, I think. And I think you'll do better on this one on the test than you did on the quiz, probably, a lot of you. And it's pretty simple. You just have to complete the square on this term and that term. And when you do that, you end up subtracting 25 here and subtracting 4 here. When you put them to the other side, you get 49. Which then, if you look at this, remember the equation for a circle, we can see the center and the radius squared over here, right? So the center is 5, -2, because we need, what was the equation for the circle? I'll write it down here for you guys. Something like this, right? X minus x naught squared plus y minus y naught squared equals to r squared, right? So I complete the square to make it match that pattern, and then once I have that, I can see that the center is where? It's at x naught y naught, and what's the radius? It's r. So for this one, it's the square root of 49, which is 7. So there's that problem. I know a lot of you got that wrong, but I think that's one that you can definitely recover from on test 3, and you do want to get that one right if I ask it again, for sure. And also, if you're still not clear on completing the square, you need to fix that, because it's going to come up again at the final, and I don't want it to hurt you if you don't know it. Okay, so and then here, we can recognize 16 is 2 to the 4th and solve it like that, right? There's another way to do this problem. You could, what would be the other way you could solve this problem if you wanted to?
I logged it.
You logged it? What happened? Which kind of log did you use?
I did like a log base 2.
Log base 2, and how'd that work?
I got 2x minus 3 equals log base 2, 16
Okay.
plus 3 divided, and then I divided all that by 2. Or no, plus 3 and then plus 2.
Right. Writing it down over here. So you added 3 to the other side, isolate the 2x, and then divided by 2.
Yeah.
And so that's what you're in. Then that doesn't That was your answer?
I got 7 over 2.
Oh, okay, cool. Because then you realized that log base 2 of 16 was what?
I don't know.
How did you get 7 over 2 then?
I used the calculator.
Oh, you have a log base 2 in your calculator?
Or I could do like the base change.
Oh, so you actually, you went to the trouble of going log base 2 of 16. You calculated that like natural log of 16 over natural log of 2, or?
Yeah.
Ah, cool. Yeah, that's a legitimate way to do it, sure. Of course, to see log base 2 of 16, the thing to make that simple and not need a calculator is that that's log base 2 of 2 to the 4th, which is 4, right? And that's what makes this 4 plus 3 over 2, which is 7 over 2. So yeah, either you use a calculator to get through the ugly thing you don't understand, or if you remember 16 is 2 to the 4th, everything kind of gets easier there, right? Oops. So I'm trying to figure out the right zoom out here to be able to write and project at the same time. Nah, good enough. All right, so what else here? Well, let's move on. Number 4. So the one on the right, a lot of you said, no, it's not invertible, and then you gave me ridiculous reasons that I don't even understand. Like, it passes the vertical line test, or because it fails the vertical line test. You're like, no, it does not fail the vertical line test, the one on the right. Actually, neither of these fail the vertical line test. But that's irrelevant. That just checks whether or not it's a function, right? The question is, does it pass the horizontal line test? It does not, right? So it fails the horizontal line test. So what I was looking here for, the best answer would be something like fails the horizontal line test or is not one-to-one. You could just say either one of those things. If you said those would be true, and then you could say therefore it doesn't have an inverse. Like that would have been fine. So I didn't take points off some of you, even though you wrote things which were not that, and some of the things that I saw were kind of like, what? So I probably like circled something and put a question mark if I had that feeling when I was looking at your solution, which means that while I didn't take points off, if I circle something and put a question mark on your quiz and didn't take points off, it means that if you did the same kind of thing on the test, I might take points off. That's a general rule of thumb. Okay, anyway. So that doesn't have an inverse because it's not one-to-one. This one is one-to-one. How do you graph the inverse? A lot of you just like took this line, right? And what I saw a lot of people do is just take this graph basically and flip it down here like this. But that's not how it goes. I mean, that's pretty, but that's not right. We just have to do this. We take the points that are on the graph of the function, in this case minus 6, 8, and flip them. So that gives you the point 8 comma minus 6 on the graph of the inverse. This point 6 comma 4 flips to give me 4, 6 on the graph of the inverse. And then I just connect the dots. That's the graph of the inverse right there. Now some of you, I circled something on your graph and I didn't take points off on the quiz, but I would on the test if you did the same thing. So some of you have extended this line on. That's not right. These are line segments. They don't go on and on. Here's one of the evidences of that. The domain of the given function is what? The domain is minus 6 to 6, right? So remember, the range of the inverse function should be the domain of the function, right? What's the range of the inverse function? Well, the y values, right? So the inverse function goes from minus 6 up to 6, like it should, right? If the line goes on and on, the range is not minus 6 to 6. It's much bigger, right? So that's a different thing. Anyway, just a comment. Any questions? You just jump in if you got questions as I go here, guys, okay? Problem 5. A lot of people had a lot of problems with number 5. So if you got this one wrong, I would say you have a lot of company. Let me address one of the algebra mistakes I saw here, which we must cease. We must cease and desist this algebra step. Like this is not helping you. Do not do this. It's bad because it's poison to your work, really. And so the thing I saw the people do, a lot of people, is basically this x over x plus 3, and I saw people go, 1 plus x over 3. What was their internal thinking here, people who wrote this? What they're thinking, right, is that you can break this up into x over x plus x over 3, right? Which of course is not true, right? What is true is if I had x plus 3 over x, I could break that up into x over x plus 3 over x. This is fine. Up on top, if you wrote that in one of my favorite professors here's classes, I won't name names, but that professor would take this, he would do something like this, and off to the side he would write bad algebra, because it's bad algebra. Like, don't do this. It's not true. I can't spell algebra, that's not a good sign. Algebra. And so like when you're making a step like that on a test or a quiz in this course, like if you have a doubt about the algebra step, right? What's a good thing to do if you doubt your step? Algebraic steps are only true what? If they're true for like all values of the variable, right? So a quick way to check yourself, and you know, if you're like you're about to do this, but you have a sense like I'm not sure I'm supposed to do that. One thing you could quickly do to figure out whether you're on the right path or not is just try putting a number in. See, if I try to put 5 over 5 plus 3 and say, is that equal to 1 plus 5 over 3, right? If this was actually true up there, that should work out. But it doesn't, see, because 1 plus 5/3 is 8/3, but 5 over 5 plus 3 is actually 5 over 8. And of course, 5/8 is not equal to 8/3, right? So like this is something you can do if you doubt your step, is just plug a number in. See if it works or not, right? I give you that advice now because we're getting closer to the final exam and you may have moments of doubt on the final. This is something you can do to try to check yourself if you're a little fuzzy, you know? I mean, it helped me when I was in algebra anyway, so. Of course, this, again, no. All right, so any questions about this? Yep. Oh, okay, so here, what we did, we said y equals f of x, and then I solve for x. So step 1, I write y minus 2 equals x over x plus 3. Then I add 2 to both sides to get to here. Y minus 2 equals x over x plus 3, right? Then I multiply by the denominator, and then I distribute that out. I collect all my terms with x to the left side, everything without x to the other side. Notice here, minus 2x minus x gives me that minus 3x. And then I factor my x out, and then I solve for x. And that, whatever is left, will be the formula for f inverse of y. And so that's why I have f inverse of y as that. Now, the other thing here, of course, is I asked you to find the range of the function. The idea here is, well, we know that the domain of the inverse function is the range of the function, right? And what's the domain of the inverse function? Well, look at the formula. What's the one thing that's not allowed? 3, right? You can't put 3 into that formula. You get division by 0. So it's easy to see that the domain of the inverse function is everything except for 3, which means that the range of the function is everything except for 3. So this is the idea. That's a little tricky, that idea, if you hadn't seen it before. I think yeah.
Are those brackets or parentheses on x, y minus 3? On the left-hand side.
Oh, here? Yeah. Either way. You could go square brackets or curly bracket. I mean, either kind of brackets would be okay. It's only these sorts of things where that starts to be more of an issue in here. Hey, listen, a lot of you had a lot of problems with this. Let's work another one of these while we got time, okay? So how about this? We have f of x equals to, let's say, x plus 1 over 2 minus x. Can you find f inverse of y for that? How would you do it? Can we do this one? What's the first step? Remember we used that 4-step process I told you guys about?
Multiply 2 minus x. Yes.
Oh, but before we can do that, I mean, I'm with you, but first we got to write this, right? And then you said multiply both sides by 2 minus x. Right there with you. Y times 2 minus x is equal to x plus 1. We're trying to solve for x, right? So multiply that out. We got 2y minus xy equals to x plus 1. Put all the x's on one side. So I'll subtract x over here. I got that, yeah. Then factor x out, right? So I've got x times what? X times minus 1 minus y. Now I can solve for x, yeah? I don't like that answer. Too many minuses, you know? Let's make it prettier. So what can we do? Factor a minus out of the top. Like that. Factor a minus out of the bottom. Like that. And you can see that the minuses cancel, right? And they leave us with what? 2y minus 1 over 1 plus y. So there you go. F inverse of y is equal to 2y minus 1 over 1 plus y. What would the range of the function be in this problem, this example? Everything except for what? Everything except for negative 1. What would the domain of the function be? So we just said that the range of the function is the domain of the inverse function, which here would be minus infinity to minus 1, union minus 1 to infinity. The domain of the function, which by the way would be the range of the inverse function, not that I asked about it, but that would be everything except for what? The one thing that makes this formula break down is the denominator being 0, which happens when x equals to 2. So throw out 2. I didn't ask that on the quiz, right? But those are reasonable questions to ask you. Certainly on the final, it's something you should be prepared for. Okay, so let's work one more of these and then I'll go on. Example 2. What if you're up against f of x is equal to 3 plus log base 6 of 2x minus 7? Find the inverse function for that. Can you do it? You're like, but there was nothing like this in the homework. That's true. There was nothing like this quite exactly in the homework, I don't think. Nevertheless, this would be a reasonable test question. Why? Because this combines the two things we've learned in the homework, right? Number one, how to find the formula for an inverse function. And number two, how to do algebra involving exponentials and logs. So but this is a kind of a new problem, so let's work it. We've got y is equal to 3 plus log base 6 of 2x minus 7. I need to solve for x. How do I do it? Can I erase my work for the example 1? Are you guys good? Now you're good, right? Okay, okay. Okay, so I'll write it again up here. I'm going to subtract 3 to the other side. Surely we can do that, right? So I'm going to write log base 6 of 2x minus 7 is equal to 3y minus 3. Right? So then what? Well, the natural enemy of the log is exponential base 6, right? So all I do is just exponentiate both sides like this. 6 to the that is 6 to the that. Now, these are inverse functions, so the left-hand side, I just get 2x minus 7. On the right-hand side, I've got 6y, 6 to the y minus 3, right? Something happened. All right, let's see here. So 2x is equal to, did I ever tell you about the student who wasn't paying attention in my class? And I confronted him. I was like, I think you're having trouble following because you're texting in class. And he's like, no, sir, I wasn't texting. I was watching soccer. It's like, that is so much worse. It's like, don't ever ask me for a recommendation letter. Because if you do, I will put that on there for sure. He asked me for a recommendation letter. Can't believe it. And of course I put it on there. So that's here. Now it was not for something external to Liberty. It was like he was going for like a tutoring position or something. But I'm like, yeah. Wow. So there you go. We solved for x. And that, of course, is f inverse of y. Golly, something's exciting over there. You guys with me? Okay, so let's move on here then. Problem 6. I think once you see problem 6, if you got it wrong, you're going to be like, oh man, I could have got that, right? What's the key idea? What's the key thing here to know about? Well, natural log of e to the x is equal to what? X. That's true for x. It's also true for 8, right? What's natural log of e?
1.
Is 1. Yes. Natural log of e is 1, so that happens. X minus 6 equals to 8, so x equals 14. This one here, by the one-to-one property, we just get 3x minus 1 equals x plus 5, which solving for x gives me 2x equals to 6, which gives me x equals to 3. Problem 8. I've seen a lot of partial progress here, guys. Like there's a lot of you have something right and something wrong. So there's work to do in problem 8 for sure for most people. Now, listen, I am not too like overly concerned for you if you didn't get the 2 right. I mean, that's tricky. How do you turn 2 into a log? Well, we're working log base 10, right? So the idea there is just that, you know, if we have like log base a of a to the x is equal to x, right? So we know that, but it works the other way too, right? So if I have 2, I can rewrite 2 as log of 10 to the 2. See, log is just 10 is the base, the common log, right? Base 10. What is 10 squared? Well, it's 100, right? So 2 is log of 100. That's how to repackage the number 2 as a log. Some of you were missing. Some of you lost track of the 3 down here. That happened to some of you. But there it is. That's that one. I will mention I'm kind of thinking about reformatting these couple questions here, like 8 and 9, as like multiple choice. I might make some multiple choice questions about this because I think it might be a reasonable format for this kind of question. Let's see here. The last one, problem 9. A lot of you just kind of like ignored the square root and just kind of like it just kind of poof. Like I don't know what to do with it. I'm just going to ignore it, right? just disappeared. And then then basically you got this kind of okay, but without the half. But that's a half power, so it pulls out to a half. And again, the power pulls the 5 out, pulls the 3 down, and so that I did give full credit to people who wrote this. That's the answer. Problem 10. Some of you just guessed the answer. Like, wow, that's hardcore. Like you're just like sitting there with a calculator, like punching numbers in until you get to something really close to 5, and you're like, there's the answer. I have to admit, that is a method. Like guessing the answer like that is a method. It's a bad method, but it is a method. But the thing is, if you did that and you didn't tell me you did it, I'm still going to take points off because you got to show your work. So for me, there's a big difference philosophically between a person who writes 2.32 down without an answer, without an explanation, versus the person who writes 2.32 down and has a sentence off to the side that says, I punched numbers into my calculator until I found numbers sufficiently close to 5 that I got 2.33. That person got 2.33. I didn't take much off because they were still very close. But and they wrote me the sentence over there telling me what they did. That was like really valuable. I want to know why you did what you did. Don't just write the answer down, please. Because I give partial credit, which means that I have to take points off when you don't show work. So show your work. Yeah. Anyway, so this one, some of you got hung up on it because you used log base 2 to solve it, right? Which is fine. Like you could solve this with log base 2, right? It's not a bad way. But if you do that, you need to know about the change of base formula, right? Because not all of you can do log base 2 on your calculator. So if I've got 2 to the x equals to 5, it is true I can take log base 2 of 2 to the x is log base 2 of 5, right? Which then gives me x is equal to log base 2 of 5, right? And that is the exact answer, right? That's it. But if I asked you for the decimal approximation, you still have to figure it out, right? So change the base formula here looks like this: natural log of 5 divided by natural log of 2. So if you have a calculator, a scientific calculator, you have natural log, right? Everybody has natural log who has a calculator that's scientific. If your calculator doesn't have a natural log, then you're using the wrong one for the test that's coming up. And then when you plug that into the calculator, you get 2.32 and stuff. But I asked for 2 decimal places, yeah? Moving on here, problem 11. Use the property of logs to combine the 2 logs like that. Now, okay, so let me talk about what was wrong. I saw a lot of people do this. Log 4 of x plus log 4 x minus 6. And I saw some people do like this gives me x plus x minus 6 equals to 2. And then they gave them 2x is equal to 8. And then they got x equals to 4, which is wrong. So what's wrong about this? What's the wrong step there? Like the wrong step is right here, right? You can't just, drop logs like that. That's not a thing. It doesn't make sense. It's not reasonable. It will get you wrong answers. Don't do this, yeah? And some of you did something different. You took 4 to both sides, right? Some other people, instead of doing that, they put 16 over here, which is kind of better. 4 squared is 16, right? But the thing is, when you take 4 to the log 4 of x plus log 4 of x minus 6, it is not equal to, x plus x minus 6. Because the way the property of log simplifies is 4 log 4 of x, 4 log 4 of x minus 6, which ends up multiplying x and x minus 6. There, you have to, anyway, don't write these things down. These are wrong. Let me erase them before they do harm. You know who I'm talking to, if you're the person who made the mistake, I hope. But anyway, so yeah, these are, if I'm not careful, if I just leave wrong equations on the board, some of you will just copy whatever I write down, right? Because you're detached from what I'm saying, you're just copying what I'm writing, and then you'll have something wrong in your notes, which would be the opposite of what I'm trying to do. Anyway, so after we take the usual properties of logs to collect it, we exponentiate both sides, base 4. And that gets us to x times x minus 6 equals to 16, which then you put all on one side, factor it. That gives you 8 and minus 2, but minus 2 is extraneous here because if you plug it back into the original equation, it fails, right? So there's that one. There are a bunch of homework problems kind of like this, right? Now, if you got problem 12 wrong, I understand. I feel your pain. I get it. We didn't spend a lot of time on these, right? I did about maybe 2 examples of this, maybe. There's maybe 2 of them in your homework, so it'll be easy to miss it. But this is a quadratic substitution problem. So you have to let y equals e to the x that takes this equation, exponential equation, converts it to a corresponding quadratic equation, which you can factor and hence solve. And when you do that, because we're looking at e to the x equals to 4 or e to the x equals minus 1, we may or may not get a solution. We don't get a solution over here because e to the x is positive. And of course, if you take the natural log here, your natural log of minus 1 will tell you error, right? Take the natural log of 4, well, you get a number. So the answer here is x equals log 4. That's the only answer for that one. By the way, I have posted this solution that we're going through right now in Canvas, right? It's there, as well as the blatant copy of quiz 3, right? Let's see here. Problem 13, a lot of you got right, so yay. If you got problem 13 wrong, here's how to get it right. Take one of the equations, solve for y, right? Then take that and plug it into the other equation. That should give you one equation and one unknown. You can solve for x. That's all you do. That's all I did up here. I take number 2, and I solve it for y. I take that, I plug it into number 1, and that gives me an equation just in x. I multiply stuff out. I get myself to 11x minus 3 equals to 8, which then gives me 11x equals to 11, also known as x equals to 1. And then I go back to my y equation and gives me y equals to 2. So, all right, a lot of you got that one. A few people got this right. A few people. This is like the last couple of problems in homework 12 for you guys, which were symbolic in nature. So the first enemy, I need to work my way to a here, basically, is the way to think of it. So to get to a, I have to get past this exponential and past this log. Notice that those aren't just inverse functions because that's the common log. That's log base 10, right? Exponential and log are not inverse functions here because they're different bases. So I take the natural log of this equation. I get log of the exponential of the common log of AB equals to the natural log of C. These are inverse functions, so I'm just left with log of AB equals log C. This is the common log, that's the natural log. Then properties of logs give me log A plus log B equals to the natural log of C. Solve for the log of A to isolate A, like this. And then take both sides and raise it to the power 10, rather exponentiate base 10 both sides. So that gives me a on this side, and on the other side we have 10 to the natural log of c minus log of b. But by properties of exponents, I can rewrite that as 10 to the log c times 10 to the log natural log c times 10 to the common log b to the minus 1. These are inverse functions, so that simplifies to 1 over b multiplication by b inverse, which is to say divide by b. So there's the answer. So, you know, that's a little bit of a trouble, but I wouldn't say that's as bad as like the formula with the big T in your homework. You know, that one was worse. Problem 15, I decided to test 3 equations and 3 unknowns on your quiz with a word problem. Maybe on the test I'll just have 3 equations and 3 unknowns, you know, I don't know. Maybe I'll do this word problem again. I haven't decided, but this one, you know, everybody really should have been able to get c equals to 3. You really should have been able to get c equals to 3 like the first week in this course, right? Most of you remember from your previous course that f of 0 is the y-intercept, right? But here f of 0 is also equal to c, right? So since 0, 3 means the y-intercept is 3, that must mean that c is equal to 3. Which of course we can get from just plugging it in, right? F of 0 is equal to 3, so I plug 0 in. 0, 0, c. So c equals to 3, which, like I said, is nice because what happens after that is we don't have 3 variables anymore, right? So when I plug 1, 6 into the equation, I get f of 1 equals to 6, which gives me a plus b plus c equals to 6, right? 1 squared is 1, and 1 times 1, right? Minus 1, on the other hand, I get minus 1 squared, which is 1, so it's still just a. But when I plug minus 1 into this formula here, right, I get a times minus 1 squared plus b times minus 1. Well, b times minus 1 is minus b. And I still have the plus c, right? And then, of course, I know c is 3, so I just clean these two up to give me a plus b is equal to 3, and a minus b is equal to 1. Now, the previous problem, I thought substitution's the right way to solve it. This one, definitely elimination's the better way, right? Just add equations, you cancel out the b's, right? So add it, you get 2a equals to 4, which gives us a equals to 2. And then I go back to one of my other equations to get b is 3 minus a, which tells me b is 1. And then put it all together. Here's your answer. I think about 10, 15 people got this right. Not just in this section, but like overall, all 4 of my sections of the 100 so people who took this quiz. Yeah. So it's not everybody gets this right, but some people do. far fewer people got the problem on the inverse function right. So, all right, now one of you had a question about one of the homeworks, so let me talk about that in the time that remains here. What was the question about?
Half-life.
The half-life problem. So what do you want to know about it? How to solve it? Okay. Well, I need some data. So like, so I think you're given that the amount at time t is equal to a sub naught e to the minus kt, right? Or maybe, I mean, something like that. Or I don't know if the letters are the same in your homework problem or not. I don't remember off the top of my head the letters. I mean, that is the formula for radioactive decay. So, all right, so let's suppose that, you know, are you given K? I think you're given K in that problem, aren't you? So they tell you K maybe is equal to 0.02 or something, you know? And then find the half-life, right? That's essentially the question, isn't it? So here's the thing. At time 0, we have a sub 0, right? Because if we plug in 0, you get e to the 0, which is 1, times a sub naught, which is just a naught. So we have a sub naught is the initial amount. The time we're looking for, the half-life, is when a of t is equal to what? Half-life is when half of the material has radioactively decayed away, right? So instead of having the amount a naught, you have a naught over 2. All right? But we still know that the formula holds, right? It's still equal to a sub naught e to the minus 0.02. I think they just give you the they may just put the number in the formula in the website, in the MyLabs question, I forget, but I think mine was 0.33 in the one I worked in class. So you see, it doesn't matter what a sub naught is, right? And so like physically, for example, if you have 100 kilograms of uranium-235, or if you have 5 kilograms of uranium-235, the half-life is the same. It's independent of the initial amount. It's just a property of the substance you're talking about. Or free neutrons, right? A free neutron has a half-life of 11 minutes. If you have 100 free neutrons sitting there and you wait 11 minutes, you should have only 50 left, statistically speaking. So the a naught doesn't matter, it cancels, right? So we just have to solve 1/2 is equal to e to the minus 0.02t. How do you solve that? And I would point out that there's a deficiency of my test, right? My test was missing that kind of problem, wasn't it? The quiz was missing that. That really should have been on the quiz, I would point out. I mean, I try to get everything, but I try to limit myself to 4 pages. Sometimes I may overemphasize something, and then as I process the... okay, so I take the natural log of both sides. What happens? We get minus 0.02t over here. And then what? Oh, sorry to the people who weren't here. I never went back to the projector screen, my bad. So then I solve for t. T equals to the natural log of 1/2 divided by minus 0.02, which I need a calculator for, you know, but now the time is given in particular units, right? It's like in years or something for the problem, I forget. So this would give me 34.66 years, something like that. Now, I forget, the homework problem has instructions like round to the nearest whatever, I forget that, but you know. Does that help? So yeah, half-life, you just set the amount equal to half the initial amount.
I got flashbacks.
Yeah, you know, I don't know if I'm talking to you guys, but it is, when I took classes about your time in my academic existence, I ended up seeing the exponential stuff, I think in like 4 different classes. Like it was in my calculus class, it was in my chemistry class, it was in my physics class, it was somewhere else too, I forget where, but anyway, it comes up a lot. So you guys ready?
I have a quick question.
Uh-huh.
So, for the final exam, is our exam on the 12th?
It's whenever the official, you know,
Because,
Where do we go check when our tests are? On campus? Is that on campus?
no, if
on
you,
Canvas, when you say like the final exams on, for the Math 121.
Canvas is garbage. Do not use Canvas.
Since next
So as a general point of order, do not use Canvas. Like, if you want me to, like, there's so many things. You send me a message through Canvas messaging. It will eat your picture. I don't even see your picture when you attach a picture to Canvas messaging. Use Outlook. It is so much better. So here's how I find it. Liberty University final exam schedule. There you go. And then we look here. And let's see, what are we? Fall 22, right? What time is it? What class? We're 210, right?
It says the 12th of December. then
Here it is.
says something.
So yes, this is what is true. Whatever it says in Canvas, don't ignore it. Where does it say that in Canvas?
Is it in here? Right there. But that's like a different section, so I didn't know.
Yeah, different sections have different, what's that?
Is the exam in here?
Exam is in here. The exam should be, yeah, in this room, 3:30 to 5:30, December 12th, Monday, right here. Yep.
So it's in this room?
This room. Yes. There's no, like, we have no common final or anything fancy like that.
It goes in my math file on the same page.
Ah.
So it is.
Oh, let me turn off that.